Hi, in this video I would like to tell you how to solve the DNA dilution problems. So we're going to take the problem where we have to dilute a DNA product which is 700 base pairs, and we have to put this into 200 microliters, and we would like a final concentration of 0.1 picomole per microliter. So the way we start to solve these problems is, as usual, we start by finding the molar weight of that particular piece of DNA. And the way we do this is that we always multiply the number of base pairs of the product by 660 gram per mole per base pairs. And so in that particular case, this gives us a molar mass, which is equal to 462,000. And the unit is gram per mole. So if we put that mass here, which is 462 kilograms, into 1 liter of water, then we've got a concentration of 1 molar, or 1 mole per liter. So we say that 462,000 grams in 1 liter is equal to 1 mole per liter. So this is here 1 mole per liter, our reference concentration. So now how do I solve the problem of getting to that particular volume and that particular concentration? Well, I'm going to take the approach where I'm just going to divide by how much smaller a volume I need and how much smaller a concentration I need compared to 1 mole per liter. So we start with the concentration. So 1 mole per liter means that we put that amount here of grams into 1 liter. But that's the same thing as saying that we take 1 micromole into 1 microliter. Okay, we use the micro unit here, so 1 micromole in 1 microliter is the same as 1 mole per liter. All right, but we don't want a concentration of 1 micromole per microliter. We want a concentration of 0.1 picomole per microliter. So the question now is, how much smaller is 0.1 picomole compared to 1 micromole? So you have the micromole, and to go to the picomoles, you dilute by 1 million. Okay, you have micromole, nanomole, picomole. So here, this is a million diluted. But we don't have 1 picomole, but 0.1 picomole. So to go from 1 micromole to 0.1 picomole, we need to dilute by 10 million. Okay, so I'm using multiply just to say that we have to dilute that many times, but you could say divide by that many times, right? So we know that we need to put 10 million times less here mass in order to divide the concentration by 10 million. All right, so the first thing is that we are going to divide this by 10 million. So that we have a concentration here in the end, which is 10 million times smaller. Now, the next thing is that we don't want 1 liter of water, we want 200 microliters. So 200 microliters, how much smaller is it than 1 liter? Well, if we multiply by 5, we get 1 milliliter. Okay, and 1 milliliter is 1,000 times less than a liter. So if we multiply by 5,000, then we get 1 liter. So that volume here, 200 microliter, is 5,000 times less than 1 liter. So in the end, what we need to do is that we need to divide 10 million times to get to the right concentration here. And we also need to divide 5,000 times, okay, to get here the right volume, which is 200 microliters. So in the end, the way we solve this problem is that we take the mass that we need to put into 1 liter to obtain 1 mole per liter. We divide by 10,000 this mass so that we get a concentration of 0.1 picomole per microliter. But that would be here the mass we need for 1 liter. So we divide by another 5,000 here in order to compensate for the fact that we want a much smaller volume here of 200 microliters. And so in the end, the solution is found by just doing that operation here. And so if you do this, you will find that the result of that is equal to 9.24 10 to the minus 6. And the units here were a gram. So 9.24 times 10 to the minus 6 gram. This is the same as saying 9.24 micrograms. So that's the solution to that particular problem here. And so I'll say it one more time because this is really what matters, is the method. So this here in blue is the mass that you need to put in 1 liter to get that concentration. We want a concentration which is 10,000 times, 10 million times less. So we need to put 10 million times less DNA in 1 liter just to compensate for the concentration. And finally, because we also want to divide the volume by 5,000, then we're going to divide that mass by another 5,000 just because that volume is 5,000 times less than a liter. So that's the way you solve these problems. At least that's the way that I suggest to solve these problems. So good luck for the next types of problems with DNA dilutions.